press the bell icon on the YouTube app and never miss another update.
Yeah, hello dear students. Now let us continue the session 2, system of particles and rotatory motion. See, in a session 1, I covered very basics, and the main points from session 1 is, one is axis of rotation. I think you remembered the meaning of axis of rotation. Axis of rotation means the line along which the rigid body rotates, and that axis of rotation may be within the system or outside the system. And one more is rigid body. Rigid body nothing but the shape and size of the body does not changes under the application of force. And you know, a rigid body have translational motion, rotational motion, and also rolling motion. Rolling motion nothing but combination of translational and rotational motion. Okay, I given some examples also. Later we entered center of mass. I think you remember the meaning of center of mass also. So center of mass means the point at which the total mass of the body is supposed to be concentrated, and I given some examples. And you know, center of mass, at the position of center of mass may present or may not present, mass may exist or may not exist at the position of center of mass. Keep in mind, this is one of the characteristics of center of mass. And one more, at the internal forces does not change the position of center of mass. I given some bomb examples. Okay, if a bomb explodes at that point, if a bomb is at rest, if it explodes, then different fragments will fly off in different directions, but center of mass remains at rest only. If it explodes at the mid-air, then different pieces will fly off in different directions, but the central particle follows parabolic path. Okay, and center of mass may be within the body or outside the body. Okay, so these points I covered in the last class. Now let me do some mathematical concepts related to the center of mass, and let me continue basic numericals related to the center of mass. Next I will continue some good level of questions. Okay, see the next one. So write the heading, coordinates of center of mass. Coordinates of center of mass along a axis, along x axis. Okay, let me find out the position of center of mass exact. So what are the coordinates? Coordinates of center of mass along the x axis I am going to find. Okay, see, to take the coordinates, let me consider only two particles. Okay, if two particles, for suppose if two equal masses are placed like this, see, if this is one disc, then you know center of mass of the disc is at the center, at the centroid. If I placed one more disc here, center of mass is at this point. And if we calculate the center of mass of these two, definitely we need coordinates. So center of mass of these two, no doubt at the midpoint. If these two are having same masses, then center of mass of these two systems, two particle system is at the midpoint of the line joining between them. Okay, so if I join a line, center of mass is here. If these are different masses, let us suppose this is m1 mass, m2 mass. If m1 is greater than m2, if this one is heavier than this, m1 is greater than m2, then no doubt the center of mass will change. No doubt this will shift towards the heavier mass. So, keep in mind center of mass is nearer to the heavier object. Center of mass is nearer to the heavier mass. Let us find coordinates of center of mass when 2 particles are given, when 3 particles given, when 4 particles, n number of particles are given. Okay, that is our target in this session. So, let me take 2 particle system. For 2 particle system I am going to find. For 2 particle system, okay, let me find the coordinates for 2 particle system, and this I am finding only along one axis. So, we will get only one coordinate. Okay. If it is a plane, we will get 2 coordinates, x coordinate and y coordinate. If it is in a 3D, we will get 3 cases of 3 coordinates, x coordinate, y coordinate, z coordinate. Now, let us see for 2 particle system along axis. Let us suppose, see this is the some origin. At here I am placing a mass m1. Okay, this is origin. So, consider a particle of mass m1, consider a particle of mass m1 at a distance of x1 from origin. I consider a particle of mass m1 at a distance of x1 from origin. Now, let me consider one more particle whose mass m2, whose mass is m2, that I am considering at a distance of x2 from the origin. Okay. So, I consider 2 particles, one is m1 particle which is at a distance of x1, another one is m2 particle which is at a distance of x2 from origin. Okay. If these 2 are different masses, then there will be a center of mass of this system. Let us see where exactly center of mass is located. Okay, we do not know right now because we do not know which body is heavier. Okay. So, let us choose a center of mass. Let us suppose, let me choose center of mass is somewhere here. It is not the midpoint. If these 2 masses are same, there will be a center, but these 2 masses are different. m1 is not equivalent to m2 and we do not know which one is greater, whether m1 or m2. Let us feel m1 is greater. If m1 is greater than m2, then center of mass is nearer to m1. See, this is the center of mass. Is it visible? Center of mass. Okay. This is the center of mass. Let us choose center of mass is here at a distance of something x cm. Cm nothing but center of mass. Okay. So, I am taking x cm is the distance of center of mass of these 2 particle system from origin. What is x cm? X cm is the distance of center of mass of 2 particle system from origin, not from here. I am taking all from origin. So, x cm is the distance of center of mass of these 2 particle system from the origin. Okay. Now, let me consider some distance. Let us suppose this distance is from m1 to this center. Let me consider distance is r1. Okay, I am choosing r1 distance from m1 particle to, see this is m1 and this is m2. R1 is the distance between center of mass and m1, R2 is the distance between center of mass and m2. Okay. Otherwise, d1, d2, m1, m2, that is not a problem. So, let me choose d1, d2 because I am okay. R1, R2, d1, d2, it is not a problem. So, let me take this is d1 Of course, R1, R2 is also not a problem. So, D2. Okay, virginal distance, let us suppose D. So, what is the virginal distance between M1 and M2? Virginal distance between M1 and M2 is D. Distance between M1 and center of mass is D1. M2 and center of mass is D2. Okay, let me recall. See, observe carefully. Very easy thing. Don't confuse by saying all these D1, D2, M1, M2. Okay, don't confuse. See, I consider two particles. Listen again. Listen again. See, I consider two particles. They are separated by distance D. Consider two particles of masses M1, M2. Separated by distance D. Two particles are separated by distance D. And M1 is at a distance of x1 from origin. M1 is at a distance of x1 from origin. And M2 is at a distance of x2 from origin. So, x1, x2 are the distances of what? x1, x2 are the distances of M1, M2 from origin. Okay, I am finding center of mass from origin. Cm is the center of mass of this system from origin. Xcm is the distance of center of mass from origin. Okay, so see all these notations. M1, D1. What is D1? D1 is the distance between M1 and center of mass. What is D2? Distance between center of mass and M2. What is the D? D is the distance between M1, M2. Okay. X1, X2. Okay. See the picture clearly. Now, target is to find out coordinate of center of mass of this system. Okay. Directly we can solve the problem in an easier way, but let us see the origin. See, here I want to find this XCM, X coordinate of center of mass for these two particle system. I want to find X coordinate of center of mass of these two particle system. Okay. Now, anyhow we know masses, if one is heavier mass, one is lighter mass, then center of mass is nearer to heavier mass. That means, so mass, no doubt it is inversely proportional to the distance. If mass is more, center of mass is very closer. Distance of center of mass is very closer. That's why written M inversely proportional to distance. If mass is more, distance of center of mass is less. That means how these two? They are inversely proportional. They are not directly proportional to each other. So, I written mass inversely proportional to distance of center of mass. Okay. So, if it is a heavier mass, distance is very closer. So, M inversely proportional to D. That means we can write MD as constant. M and D as constant. So, you know MD constant means if PV constant, P1 V1 is equal to P2 V2. Okay, in a Boyle's law and other thing. Here MD as a constant. So, we can write M1 D1 which is equivalent to M2 D2 for two particles. If it is 3, M3 D3. So, M1 D1 is equals to M2 D2. Okay, M1 D1 is equals to M2 D2. So, identify the D1 value from this diagram. Don't confuse by seeing this diagram. Very easy thing. Observe carefully. Okay. So, M1 D1. D1, see, D1 is what? Distance between M1 to the center of mass. This is D1. We can write this D1 as, see, from origin to center of mass is XCM. From origin to center of mass is XCM. If I remove this X1, see, this is xcm. From origin to center of mass is xcm, and here is x1, and this is d1. So d1 we can write xcm minus x1. d1 nothing but xcm. From xcm, if I subtract x1, I will get d1. See, from xcm, just subtract x1, then we will get d1. So we can write m1 d1 as this d1 is equivalent to xcm minus x1. Observe carefully, xcm minus x1. So xcm minus x1, d1 nothing but xcm minus x1. Got it? Now m2 d2. Observe d2 from the diagram. You observe it from diagram. Yeah, this is d2. So if I remove this xcm from this x2, see, I want to get only this value d2, x2, and see, this value only d2. This is d2. So x2 minus xcm, x2 minus xcm will gives d2. Observe carefully. x2, from this x2 you subtract xcm, then you will get d2. So x2 minus xcm is d2. Observe carefully from the diagram. Now multiply in a general way. So m1 xcm minus m1 x1 is equals to m2 x2 m2 xcm. Okay, just I multiply m1 xcm, m1 x1, m2 x2 minus m2 xcm. Take this xcm in one side and m1 x1 on other side. So let me write here. So m1 xcm plus m2 xcm, because I taken xcm value one side. Take this minus m1 x1 to the right. m1 x1 plus m2 x2. If I take xcm common, then m1 plus m2, which is equivalent to m1 x1 plus m2 x2, and xcm we will get m1 x1 plus m2 x2 by m1 plus m2. See, this is the x coordinate of center of mass. Okay, so formula is easy and we can solve problems also in a easier way. Okay, so here I use these assumptions. Okay, here I consider two particles separated by a distance d, and center of mass is at a distance of xcm from origin. First particle at a distance of x1, second particle at a distance of x2 from origin, and I use center of mass is center of mass is nearer to the heavier mass, then I written m inversely proportional to d, that means m and d constant. So m1 d1 is equal to m2 d2, and I written d1 from this diagram. Observe the diagram carefully, and d2 from the given diagram. So finally I got xcm is equals to m1 x1 plus m2 x2 by m1 plus m2. Yeah, check it. Take this. Our target is to solve problems. So I got x coordinate of center of mass. Write this. Draw the correct diagram. This is for only two particles. If they given 3 particles, we can expect direct formula. For 4 particles, 5 particles, n particles, okay, plenty. Okay, we can solve problems in a easier way. So take this, I will continue some more steps. So finally I got x coordinate of center of mass is for 2 particle system is m1x1 plus m2x2 by m1 plus m2. Okay, let me extend. Okay, let me rub this one. Yeah. Draw the correct diagram, then everything will be clear. See, observe 2 more steps to solve some problems. See, for suppose, right now originate here, okay. So if the origin is here and if the first particle is at a distance of x1, then coordinate of center of mass is m1x1 plus m2x2 by m1 plus m2 if the origin at this point. For suppose if the origin, if you take at m1 position, if the origin is shifted to m1, then how the formula change? If the origin shifted to m2, let us see the formula. So if this origin shifted to m1, see, if origin shifted, if the origin is shifted to position of m1, let us see how the formula change. If this origin shifted to m1, then which is going to be 0? See, indirectly if it is shifted, x1 is decreasing, x1 is decreasing and reaches to the m1 means what is x1? x1 0. So if this origin taken to the m1 position, then x1 becomes 0. So x1 coordinate is 0, x1 is 0 because origin will be shifted here, and from here to here is x2. This x2 from origin to m2 is x2 distance. x2 is equivalent to d because from here to here also d. So we can write x2 is equals to d, x2 is equals to d, okay, and center of mass is here to this x, this will be shifted from here to here is xcm, and to find xcm, see, x1 is 0, okay, x1 0 and xcm will be shifted, xcm from here to here nothing but d1, xcm nothing but what? xcm, see, origin is shifted here, xcm nothing but d1, xcm nothing but d1, okay, this will be shifted here. So xcm nothing but d1 and xcm nothing but m1x1 plus m2x2 by m1 plus m2. So m1x1 plus m2x2 by m1 plus m2. So xcm nothing but d1. So d1 m1 x1 0, x1 is 0. So this is becomes 0. m2 x2, what is x2? x2 becomes d by m1 plus m2. So distance of center of mass from m1 is d1 because center of mass is at a distance of d1. So distance of center of mass from m1 is nothing but m2d by m1 plus m2. See, opposite mass into distance by total mass. Opposite mass complete distance, distance between the particles by total mass. So m2 d by m1 plus m2. And similarly, let me write directly now. Similarly, if origin is shifted to m2 position, then in place of d1 you write d2, in place of m2 you write m1 into distance by m1 plus m2. Okay. So I will give you in a problems in a detail. So right now just I written d1 is m2d by m1 plus m2, d2 is m1d by m1 plus m2. Okay, if I add d1 plus d2 you will get d, because d1 plus d2 nothing but what? D. Okay, so don't worry, I will give you in detailed in the coming problems. So no need to confuse. Here distance of center of mass from m1 is d1. What is the formula for d1? d1 nothing but opposite mass is m2 into distance, okay, distance between two particles by total mass, m2d by m1 plus m2. And if you want to find out distance of center of mass from m2, then d2 which is equivalent to m1d, opposite mass is m1 into distance by total mass. Don't worry, I will give you two problems as example, then everything is going to be clear. So write down this one first. I will give you some basic numericals to understand how this formula is coming. See, if the origin is shifted here, then this is XCM, because XCM starts from here. XCM, this XCM nothing but D1. D1 formula m2d by m1 plus m2. Opposite mass into distance between the particles by total mass. I will give you two simple numericals to understand this. Yeah, see, I written distance of center of mass. Okay, okay. See one basic numerical based on previous formula. So let us suppose, okay, let me write one simple problem. Two particles of masses 4 kg and 6 kg are separated by a distance of 4 meter. Then find distance of center of mass from 4 kg, and also you try to find from 6 kg. See, I given very simple numerical to get some confidence. Okay, see, given two particles of masses 4 kg, 6 kg separated by 4 meter gap, then Our target is to find out the distance of center of mass from 4 kg and let us find from 6 kg also. Okay. See, they given two particles. Let us suppose this is particle M1 whose mass let me take 4 kg and this is M2 is 6 kg, separated by how much now? 4 meter. Okay, 4 meter. Target is to find out distance of center of mass from 4 kg and also from 6 kg. See, to find this one, distance of center of mass from first one, let us suppose this is D, this is D. Recall the previous formula. Distance of center of mass from first body is D1, of course this is XEM. Formula is opposite mass into distance by total mass. Otherwise use general formula, XEM formula, M1 x1 plus M2 x2 by M1 plus M2. Identify the coordinate. Here the coordinate is 0, 0 comma 0, 0. Here the coordinate is 4 comma 0. Okay, 4 is the coordinate, only x coordinate. Now see, this D1 is equal to M2D by M1 plus M2. What is M2? M2 is 6. I given some simple numbers. D, what is D? D is 4. M1 plus M2, 4 plus 6, 10. Okay, so 2, 3 is this is 5 is 12 by 5 meter from where? From 4 kg mass. 12 by 5 meter from 4 kg mass. So, distance of center of mass from 4 kg is somewhere. This is the center of mass. From what, at what distance? 12 by 5 from M1 mass. Okay. If you want to find from M2, from M2 just use other formula D2, that is nothing but center of mass. From M2 opposite mass is M1D by M1 plus M2. What is M1? M1 is 4 kg, distance is 4 by 4 plus 6, 10. This is 2 5 8 by 5 meter from 6 kg mass. So, if you add 12 by 5 and 8 by 5, you will get 4. Okay, 12 by 5 plus 8 by 5. So, 8 and 20 by 5, you will get 4 meter. So, if you want to find distance of center of mass from this body, just you do opposite mass into distance, total distance, gap between them by total mass. If you want to find center of mass from here, opposite mass into distance by total mass. Otherwise, take the coordinates. Here the coordinates are 0, here the coordinate is 4, 4 comma 0. Then substitute in a regular formula. What is regular formula? M1 x1 plus M2 x2 by M1 plus M2. So, let us see. Here the coordinates are 0 comma 0. Anyhow, I am not using y coordinate because I am targeting only x coordinate. Here 4 comma 0 because from here to here is 4, 4 comma 0. Then recall our basic formula. What is our formula? XCM, which is equivalent to 2. XCM is equals to M1 x1 plus M2 x2 by M1 plus M2. What is M1? 4 into 0, 0 plus M2 x2, 6 into 4. See, you are getting same. M2 x2, 6 into 4 by M1 plus M2, 6 plus 4, again you will get 12 by 5 meter from 4 kg. Okay. So, you can use XCM formula, otherwise you can use D1, D2 formula. So, D1 is the distance of center of mass from M1, D2 is the distance of center of mass from M2. I am choosing D1, D2, R1, R2, D1, D2, X1, X2, whatever may be. Okay. So, you try one more, take this, very basic level of question because plenty of varieties are there. I will try to show everything. Let us cover the basic things. So, distance of center of mass of this. Let us solve one problem from NCERT. Same type of question is given in NCERT. Okay, you follow the exact matter, but I am giving an example. Okay, by using this you try to solve the NCERT problem. Take this, I will give you one problem from NCERT. Data may be same or may be little different. You follow the NCERT data. Here I will use some simple example. See, okay, I will give you outline data. The same model is there in NCERT textbook. See, in HCl molecule, hydrochlorine. So, in HCl molecule, the H and Cl are separated. I am giving outline data. Okay. In a hydrochlorine molecule, hydrogen atom and chlorine atom are separated by something 1.227 angstrom. I think you know 1 angstrom value. 1 angstrom is 10 raised to minus 10 meter. So, in a hydrochlorine molecule, hydrogen atom, chlorine atom are separated by a distance of 1.27 angstrom. Then find distance of center of mass, from hydrogen atom, okay, from hydrogen molecule, okay, hydrogen atom, and they given mass of hydrogen, let us take as a m, mass of chlorine take approximately 35.5 times of m. Otherwise, you can take u I think atomic mass unit. Here I am taking mass of hydrogen as a m, mass of chlorine becomes 35.5 times then mass of hydrogen. Okay. So, this is the data. Target is to find out distance of center of mass from hydrogen atom. See, this is the hydrogen. Okay. So, m1 nothing but mass of hydrogen. Let us suppose they are separated, not this much distance, very small. For understanding point of view, I drawn like this, and distance is given 1.27 angstrom. This is m2 nothing but mass of chlorine. Target is to find out distance of center of mass from this. Then you know clear. To find the distance of center of mass from one mass, just you take opposite mass. Of course, that is possible by taking m1 x1 plus m2 x2 by m1 plus m2. Instead of that, opposite mass into distance by total mass. Opposite mass into distance by total mass. So, let me write xem. Opposite mass is m2 into distance between the molecules d. Okay. In this nuclei, the molecules are H and Cl. Okay. By total mass m1 plus m2. Okay. If they ask you to find distance of center of mass from chlorine, then you write m1 into d by m1 plus m2. But in a question they are asking from hydrogen atom. So, m2 into distance by m1 plus m2. Otherwise, use regular formula m1 x1 plus m2 x2 by m1 plus m2. Okay. x1 is 0, x2 is d. x1 is 0, 0 into m1, 0. x2 is d, m2 into x2, nothing but m2d. Same formula you will get. So, what is m2? m2 is mass of chlorine. Mass of chlorine how much now? 35.5 times of mass of hydrogen. m2 is 35.5 times of mass of hydrogen. into distance. Distance how much? 1.27 angstrom. So you will get the answer also in angstrom. I think you remember 1 angstrom value 10 raised to minus 10 meter by m1 plus m2. What is m1? m1 is mh. m1 nothing but mass of hydrogen. Mass of hydrogen is how much? They given 1 u, otherwise they given m. I taken some simple example like m. m2. What is m2? Mass of chlorine. How much is? 35.5 times of m. So 35.5 m into 1.27 angstrom. This is 36.5 times of m. M gets cancelled. So 35.5 by 36.5 into 1.27. Okay, now I am getting 35.5 into 1.27 divided by 36.5. So if you solve this, you will get approximately 1.235 angstrom. Okay, approximately you verify this now. Okay, you verify the calculations. So approximately I written. So you verify this calculation exactly. So I am getting approximately, see it is less because 35.5, this is 36.5, this is more. So the value, the resultant value no doubt less than this 1.27. That's why I expected written 1.234 or like that. Okay. So verify this calculation. I got distance of center of mass from hydrogen molecule, I got it as 1.23 angstrom. Okay. So follow this process to solve some easy level of questions. See, this is NCERT problem. Maybe the data is same or may not be same. The way I am showing here now. Okay. Use this same way to solve NCERT other questions also. I will try some other questions. See, we are calculating center of mass only for a one axis. Okay. Next we will try in plane, 3D and all. Yeah, let me give one more question. Okay, along x-axis only I am going to find the center of mass. They given n number of particles. Okay, they given n number of particles. So let me write the question in outline way. So when n particles of masses m, 2 times of m, 3 times of m, 4 times, 5 times, so on n times. So they given n number of particles, okay, of masses m, 2m, 3m, 4m are placed at a distances of 1 meter, 2 meter, 3 meter, 4 meter, so on. Observe carefully. This is mass, this is meter. Don't confuse. Masses m, 2 times of m. I think you may confuse with the m symbols. So 1 kg. I think this is better for you. Okay. 3 kg, 4 kg. Then it's not a confusion. Okay. So 1 kg, 2 kg, 3 kg, 4 kg, so on are separated by what distance? 1 meter distance, 2 meter distance, 3 meter, 4 meter, and so on. Then find distance of center of mass from origin as shown in figure. So I am going to draw the diagram. Okay, see the diagram looks like this. This is the origin. From origin 1 kg will be placed here, 1 kg placed at 1 meter, 2 kg placed at 2 meter from origin, 3 kg at 3 meter, and so on, 4 kg at 4 meter, 5 kg at 5 meter, 6 kg at 6 meter, n kg at n meter. Okay. Now target is to find out distance of center of mass from origin. Yeah, see, so far we know for two particles distance of center of mass or coordinate of center of mass is xcm is equals to m1x1 plus m2x2 by m1 plus m2. If they given three particles, then follow the same formula, m1x1 plus m2x2 plus m3x3 by m1 plus m2 plus m3. For four particles, follow m4x4. Now n particles, then tell me the formula. For n particles, we can write distance of center of mass from origin, means x coordinate of center of mass from origin is m1x1 plus m2x2 plus m3x3 so on mnxn by m1 plus m2 plus so on mn. Okay. Next I will write in plane also in 2 dimension, ycm we will get, y coordinate of center of mass. In a 3 dimension zcm will come, z coordinate of center of mass. So far I written only 2 particles, that I am slowly converting into n particles. For n particles, m1x1 plus m2x2 plus m3x3 so on mnxn by m1 plus m2 plus m3 and so on mn. Okay. Now substitute all the values. See, this is m1 mass, m2 mass, m3, x1, x2, x3, m1, m2, m3, x1, x2, x3. Substitute the values and get the result. Okay. You will get some binomial equations. Okay. See, let me find. xcm is equals to m1. What is m1? 1 kg. x1 1 plus m2 2 kg, x2 2, 3 so on by 1 plus 2 plus 3 so on n terms. Okay. See, this is 1 square, 2 square, 3 square, this is n into n, this is n terms. Now, xcm is 1 square, 2 square, 3 square, n square. So, we can write summation. See, this is the symbol of summation. Okay, for first PUC students especially. Okay, for second PUC students all the things are very easy. Now for first PUC students, keep in mind this is summation symbol and this is summation of n square sigma, summation of n square. The downside is summation of n. Okay, don't cancel this n and n and summation. Okay, follow some mathematical formulas. In a mathematics there are some formulas, summation of n formula, summation of n square formula, summation of n cube formula. Okay. So, summation of n formula, n square formula I am going to write now. Okay, based on given problem I am going to use some mathematical formulas. See, summation of n square formula, keep in mind it will come in mathematics, n into n plus 1 2n plus 1 by 6 So it will come in mathematics. Keep in mind, summation of n square formula, n into n plus 1 and 2n plus 1 by 6. Summation of n formula, n into n plus 1 by 2. Keep the formulas in mind, n into n plus 1 by 2. Okay, if you are second year students, then these are nothing for you. So for fresh students, for first PUC students, keep all these formulas in mind. N into n plus 1 to n plus 1 by 6 for summation of n square. Summation of n is n into n plus 1 by 2. So n into n plus 1, n into n plus 1 cancelled. This is 2 and this is 3 is. Now the resultant answer is XCM is equals to 2n plus 1 by 3 is the required answer for this problem. Okay, 2n plus 1 by 3, 2n plus 1 by 3. Okay, so this is for n particles. Anyhow, for 2 particles we know m1 x1 plus m2 x2 by m1 plus m2. For 3 particles m3 x3. For n particles we are using summation of n square. Okay, so we can write other also. You try this and keep this summation n formula, summation n square formula. Take this. Okay, in the same way, see the same problem. If they given this is at 2 meter, 4 meters. Okay, let me give one more data. See, write down the same problem. Here I am going to change the masses, I am going to change the distances, n particles again. See, same 1 kg, 2 kg, 3 kg, so on. When n particles of masses 1 kg, 2 kg, 3 kg and so on are placed at distances of 1 meter, 4 meter, 9 meter, so on. 1 meter, 4 meter, 9 meter, so on from the origin as shown in figure. Then find the distance of center of mass from origin. Just I am changing the values. Here in place of 1, in place of 2, how much they given? 4. In place of 3, 9. 1, 4, 9, some other values. Okay. Okay, 1, 4, 9, 16, so many. Now try this. 1 kg separated by 1 meter, 2 kg separated by 4 meter, 3 separated by a distance of 9 meter from origin. Then here the values will change. You try this. Again one more mathematical formula will come here. Yeah, substitute the values. This is also for n particle system. Yeah, m1 is how much? 1 kg, x1 1, m2 2, x2 4, m3 3, x3 9, so on. See, 2 square, 3 square. This is 1 plus 4 plus 9, so on. Here we can write XCM is 1, 2, 2 square, this is 2 square, total 2 cube, 3, 9 is 3 square, total 3 cube, so on you will get any cube. 1 cube, it's nothing, okay. This is 1, 4 nothing but 2 square, 9 nothing but 3 square, so on n square. Now we can write this is a summation of n cube formula and this is summation of n square. Summation of n cube, summation of n square. Again one more formula will come, summation of n cube. So far I written summation of n and summation of n square. Now n cube. So let me write summation of n cube formula. So let me rub this side, or otherwise let me write here. Is it okay? Okay. Let me rub here. So XCM is summation of n cube formula is n into n plus 1 by 2 whole square by this is n into n plus 1 to n plus 1 by 6. So this can be written as, see, n into n plus 1 square is there and 4. So let me write in a double time. So directly we can write so this can be written as n plus 1 by 4. This is n plus 1 to n plus 1 by 6. n plus 1 okay, and this is 2's are 3's are, so this 3 will come to the top. 3 into n plus 1 by 2n plus 1 is the required answer for this problem. Check these calculations. So I think I did a small mistake here, sorry. See, I did a small mistake. See, what is M1, M2? M1 is 1, M2 is 2, I taken x1, x2. So what is M1? M1 is 1, M2 is 2, 3, so on. So this is 1 plus 2 plus 3, so on n. This is nothing but summation of n. I have taken summation of n square, but what is this? Summation of n. So XCM is equals to summation of n cube formula, n into n plus 1 by 2 square. Summation of n is n into n plus 1 by 2. Here one square and this one cancelled. N into n plus 1 by 2. Okay, change this. Earlier I have taken M1 as x1 value I have taken, M2 as x2 I have taken. So that is wrong. M1 is what? 1 kg, M2 2 kg, M3 3 kg. Then see this one, n into n plus 1 by 2.